critically endangered ours. So all of them are like, dang, we better do something about this dam because we're running low on salmon. But in Santa Barbara, it's like, wait, we had 4 last year. So we have been forced by law, and it's a good thing that we're kind of a hippie community because we were also willing to do this. But because our salmon are more rare, we were some of the first in the western states to implement these salmon conservation practices. It just so happens that our dam, with its relatively small run of salmon, is more salmon friendly than most others in the world. Ours are just super endangered, so we kind of didn't have a choice. Finally, at the end of your reading packet, there are 3 articles that have cool details about dams. 53, about the challenges of taking them down. 54, please look up. You can read this in like 45 seconds. There's no excuses. About how the Colorado River is starting to move sediments through the reservoirs. They are trying sediment flow experiments in the last couple of years. By now, if we know enough that I can teach you about it, people on the Colorado have known for decades that the sediment thing is a problem. So they're even starting to try solutions. You should read number 54. And the last article, number 55, about how the Colorado River fish are screwed. Remember, they're not all salmon. So here they give you a whole list of fish on the Colorado that have other problems that are not just the migrating salmon problems. I'd like to bridge the gap in a few of our study goals. So we talked about number 26, this one, a couple of days ago. Then we skipped ahead to number 34. So quickly in number 27. Number 27, where does coliform bacteria come from? So when you hear that there are high levels of bacteria at Henry's, that means there's a lot of poo in the water. That's the end of the study goal. Number 28. How can nutrients be a problem if we all need them to survive?
Algae blooms.
Algae blooms are not necessarily a problem.
The decomposing about it, the thing we normally
What Danielle said. Yeah.
So you keep talking about when they die, but also in the reader or in the textbook, it talks about the floating algae mass, which is a big deal, and that blocks all the sunlight from going down.
So here's the distinction. Algae blooms in lakes and in some slow-moving surface waters like tropical rivers, those algae blooms can be a problem because of the algae mass.
Yeah.
By the way, blocking light is bad, but probably the single biggest problem is the algae mat prevents gas exchange. So it's true that an algae bloom can be bad, but that's a very specific case. Lakes and slow-moving tropical surface water. Eutrophication is what we call the problem with too many nutrients, but just so that we're clear, the problem is not actually the nutrients. It's the fact that they don't last forever.
But if there's if we're polluting into a river or something, and we're supplying it with a constant stream of nutrients, correct?
Yeah.
When are the algae going to die if we're supplying it with a constant stream of nutrients?
Well, remember that surface deposition of water is not consistent. There's a rainy season and a dry season. So you've got your base level nutrient load. That could be, for example, our wastewater treatment plant putting a pretty consistent nutrient flow every single day to the ocean. That's your base level consistent nutrients. On top of that, when it rains the first time in October, what happens to every surfer that goes out to the pit?
They get sick. Get hep C.
Yeah. They get hep or ear infections or sinus infections or throat infections. Remember, there is some base level, dependable, reliable, consistent nutrient flow, but the problem is not that. The problem is the seasonal burst of nutrients that come from that first storm. Imagine every dog poo, starting in March or April, is sitting in the open until that first rain in October, November washes them all to the pit. That's like 4 or 5 months of dog poo delivered to Henry's Beach in a period of like a couple of hours and you get a big storm. That's a spike in nutrients from the storm. And that's the danger. Not when the nutrients first hit the water. Because remember, nutrients means more productivity. So actually, the first thing that happens with eutrophication is an algae party. They're like, hey, we got more food, more productivity, woo! You can see it. Algae blooms. Now, algae blooms are not bad. That's just more seafood for phytoplankton. Sorry, for zooplankton. So when the algae go off, all the little bugs are like, hey, it's a bug party! And when you've got clouds of bugs in the water, it's like, it's a little fish party! Remember, the beginning of eutrophication is not bad. It's actually really good. You get a burst of life, more productivity, more primary consumers, more secondary consumers. The sharks have big fish to eat because the big fish are eating the little fish. Little fish are eating the bugs, and the bugs are eating the algae. Good. The flip side is that surge of nutrients will come to an end after that one big storm in the fall, on our case, or after peak runoff along the Mississippi in the spring. Once that nutrient volume goes down, the algae are like, wait, what? Where's all my nutrients? And all the bugs are like, wait, where'd all the algae go? And all the little fish are like, boy, am I hungry. And as the bloom collapses, now we've got a problem. It's not the burst of life. It is the burst of death that comes afterward that provides, please look up, biodegradable waste, which creates a dead zone. So watch. Nutrients, good. Peak productivity, fine. Nutrients will eventually run out. Uh-oh. All that stuff will die. Uh-oh. The decomposition of all the dead stuff uses up the oxygen. Now you've got a problem with all the dead stuff.
And also, like, when oxygen levels drop, it becomes like a positive feedback loop.
Yeah, exactly. Because then everything suffocates and that causes more death.
More things keep moving.
And it is a positive feedback loop until water gets stirred and oxygen is added.
Yeah, is it any of the pollution algae that does, or is it the stuff like the normal below the surface down as well?
Technically, calcareous algae is pretty much not bothered by oxygen levels, so calcareous algae would survive. And most mega algae,
Like the ones
like kelp, most of that, I'm guessing could survive. I think there's benefits to multicellular.
But so you said it's the spike in nutrient increase faster than why some places require to remove the nutrients from the wastewater before.
Because those are environments where the water's either hot enough that oxygen levels are already limited, or more likely, those are places that discharge the surface waters. What our tour guide was telling us yesterday is that here in Santa Barbara, their limits for nutrients going out to the ocean is higher than our raw sewage to begin with. Because it's the ocean, they can take the nutrients and just stir it all up. That spot in the ocean is not a scary spot. But if you're just starting the surface water, like lakes or certain rivers, but they have really low allowable nutrients because those environments are prone to algae blooms as it is, or prone to low oxygen as it is. Watch this. I'd like everybody to notice that is one of the biggest watersheds on Earth, and you can imagine that watershed includes the Corn Belt and a bunch of really big cities. So we have agricultural runoff, we have urban runoff, and by the way, we have a lot of natural runoff too. Now, eutrophication can be a natural process. With no humans, the flood season of the Mississippi watershed would still be dumping out a lot of cow poo or buffalo poo or mountain lion poo and dead leaves and seagull poo and whatever. Remember, because surface water is rhythmic, nutrient supply is also rhythmic. Does that make sense to everybody? So there is such a thing as natural eutrophication. In the absence of humans, you still get eutrophication. But humans tweak the water cycle to increase the spikes, and they add nutrients to really increase the spikes. So if you have a place that's already a eutrophication risk, and then you add humans, now you've got a problem. This is what I call a eutrophication risk. That is shallow, isolated water in the tropics. So it heats up, doesn't mix a lot, and is inherently low in oxygen because it's tropical to begin with. Still air, still water, shallow, a lot of sunlight, and those conditions peak about a month after peak water flow. So it's like, whammo, all these nutrients come out, and a month later, it is the stillest and hottest. So this is the world's biggest dead zone. Year after year, it's been getting bigger and 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 bigger since we've been looking for them. But there's a lot of little ones all over the place. Want to talk more about 28? 29 is easy, your book should be fine. 30 and 31 are the last two study goals that I wanted to talk about. Number 30 is about sediment pollution. Now you remember I've talked about the problem of blocking sediment. Here's the funny thing. Sediment in other rivers is the number one water pollutant on Earth by mass and by volume. It is the most common pollution put in water. Anything that causes erosion, has lost topsoil, that's one problem. And then that topsoil ending up in water is the other problem. We've always talked about erosion as the loss of topsoil. Now that we're in the water unit, what happens when the stuff reaches the water? I've got a list. One, the water gets hotter because it's darker and because sediment has thermal mass. So sediment pollution heats water. Number two, sediment pollution blocks sunlight, so it kills plants. Number three, it smothers egg beds. A lot of fish and insects lay their eggs on the bottom, and when they get buried by sediment, you can imagine that doesn't work very well. Number four, it clogs surface water, which can create flooding. If your canal gets full of sediment, then it's not going to do you any good when there's a bunch of water. You're right with me. No, that's actually my whole list. The main activities that cause sediment pollution are the main activities that cause erosion. Agriculture, logging, construction. Agriculture, logging, construction. The three big erosion hazards are the big set of pollution problems. Yeah.
There's like an example of how to solve